Welcome to Medical Learning Hub. Today we have this question. We're supposed to prove by induction that 1 squared plus 3 squared plus 5 squared plus dot 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 plus into bracket 2n minus 1 squared is equal to 1 over 3 n into bracket 4n squared minus 1. What does prove by induction involve? It involves a number of steps, but it's all about proving that if the statement is valid, if the statement is true for the value of n equals 1, then it will be true for value of n equals k. And if that is true, then it will be true for value of n equals k plus 1. And if that is true, then it is true for all values of n. That is all about proving by induction. So let's go. Start with, let's have our solution there. Let's start with n equals 1. This is left hand side, this is right hand side. So on the left hand side we take the last term, which is 2n minus 1, this is squared. And the right hand side we take 1 over 3n, then 4n squared minus 1. So what do we do here? We substitute for n equals 1. So here we shall have 2 times 1 minus 1, then squared. On the right hand side we shall have 1 over 3 times 1, then 4 times 1 squared minus 1. So 2 times 1, this is 2, 2 minus 1, 1, 1 raised to power 2 gives us 1. And on this side we have 4 times 1 squared, that is 4, 4 minus 1, 3, 3 times 1 over 3 also gives us 1. So we have done the first part we're supposed to prove for n equals 1. What if now we go for this? Now for n equals k. For n equals k, we simply substitute the values of k in place of n. So we shall have our statement as 1 squared plus 3 squared plus 5 squared plus dot dot dot, then plus. Here we shall have 2k minus 1 squared. And on the right hand side, we shall have 1 over 3. In place of n, we put k. Then 4k squared minus 1. Okay, the statement will definitely be true. Why? Because now n equals k and our n was 1. So if 1 is constant and the k is constant, then the statement will hold true. So what is next now? Now we have to go for the statement whereby n equals k plus 1. For k equals n, or for n equals k plus 1, for n equals k plus 1, we simply add another term which will involve k plus 1 on both sides of our statement. So the left hand side will become, this is 1 squared plus 3 squared, then plus 5 squared plus dot dot dot, plus we had 2k minus 1, this is squared. Then we are going to add another term which is 2. This time around our k is k plus 1. Then we minus 1, this one is also squared, equals the right hand side. Our right hand side now will become 1 over 3. 1 over 3, this is k, into bracket 4k squared minus 1. Then we add similar term, which is bracket 2, this is k plus 1 minus 1 squared. This is what we have. So try to simplify. The left hand side will become 1 squared plus 3 squared plus 5 squared plus dot dot, plus then 2k minus 1, this is squared, plus here we shall have 2k plus 2 minus 1, so it will be 2k plus 1 squared equals the right hand side. Our right hand side will become 1 over 3, this is k, then 4k squared, this is minus 4k squared minus 1, it's this one, then plus, we simplified this one and we got 2k, plus 1, then squared. There we are. Okay, now due to space and time, let's deal with the right hand side because the left hand side is not going to change at this stage. So let's carry on the right hand side. Here we shall have 1 over 3k, 4k squared minus 1 is the difference of 2 squares, which will give us 2k minus 1, then 2k plus 1. Okay, then plus we have again 2k plus 1 squared. Taking the common factor outside, let's take this fraction, so let's take it outside. So we shall take 2k plus 1. Here we have 2k plus 1, then and 1 over 3. So our common factor, let it be 3, then 2k plus 1. Then let's have this kind of bracket. If we do that, now here we shall remain with this term from here to there, which is k, then 2k minus 1. Okay, what about this one? This one we shall remain with 2k plus 1. Okay, can we simplify it? Definitely yes. So 1 over 3, this is 2k plus 1, into bracket. This one gives us 2k squared minus k. Oh, sorry, something is missing here. We took out 1 over 3, so this term is supposed to be multiplied by 3. It's just an error, don't mind. So it will be 3, then 2k plus 1. Okay, so here it will be plus this times this. This is 6k, yes, and that one will give us 3. That's what we have, equals 1 over 3, then 2k plus 1 into bracket. This is 2k squared, 2k squared. Minus plus, this will be plus 5k. Do we have a constant? Yes, that is 3. It will be like that. So inside here we have the product of two numbers, which is 6, and the sum to give us 5. So that is 2 and 5. If it's 2 and 5, then this is what we get, 1 over 3, then 2k plus 1 into bracket. We shall have, this one gives us k plus 1. Another bracket will be 2k, yes, plus 3. 2k plus 3, it will be like this. Yeah, 2k squared. Then, yeah, this times this is 2k squared. And this times that one, 3, here 5, yes. That's what we get. Okay, can you simplify it further? I think that's where it has ended. Now let's put our information together and see what we can get at the end. So our statement now becomes 1 squared plus 3 squared, then plus 5 squared plus dot dot dot, plus we have 2k minus 1 squared, then 2k plus 1 squared equals the right hand side, which is 1 over 3, then we shall have k plus 1, then 2k plus 1 also. Then we have 2k plus 3. Now let's check the last two terms, these ones for the left hand side, and this one, and try to substitute for k equals 1 and see if the statement is true. So we shall say for k equals 1, let's have our left hand side here, and let's have our right hand side somewhere around there. So the left hand side, we're going to take these two terms, that is 2k minus 1 squared plus then 2k plus 1 squared. On the right hand side, we're going to take the whole of that, 1 over 3 k plus 1, then 2k plus 1, 2k again, plus 3. Okay, let's put 1 in every bracket. So here we shall have 2 times 1. This is 2 times 1 minus 1 squared, then plus again 2 times 1 plus 1 squared equals 1 over 3. Into bracket, this is 1 plus 1. Then here it will be 2 times 1 plus 1. And here it will be 2 times 1 plus 3. Okay, the left hand side here, this times this, we are getting 2. 2 minus 1, that is 1. 1 is squared. Here we have 1. Then plus 2 times 1, that is 2. Plus 1 becomes 3. 3 squared, this is 9. And the right hand side, we shall have 1 over 3 times 1 plus 1, this is 2. Then it times again. 2 plus 1, this is 3. 2 times 1 plus 3, this is 5. So this 3 we cancel this 3. Then what do we get? 2 times 5. So the left hand side we get 10, and the right hand side we also get 10. So what does this mean? This means that therefore the statement is valid or is true for n equals 1, n equals k, then n equals k plus 1. Then we shall say, then it is valid. It is valid for all values of n. Then we put the comment, hence proved. Okay, this is how we finalize. Thank you for watching. Looking forward to be with you in the next video.